Hello friends, welcome to Aromaticity part 3 video. Among the following compounds, the one which has highest dipole moment is, this question is from net exam. Regarding the dipole moment, just remember there are two distinct charges that stands out, plus minus, that should stand out. If this is there, then the dipole moment will be highest for that. Now just remember, if a compound it is aromatic, then it will be very stable. It will be a stable compound, very stable compound. The next thing it is, if it is anti-aromatic, then it will be highly unstable. This thing that is very important. Aromatic very stable, anti-aromatic will be unstable. So any compound that is after they become dipole, if they convert into aromatic, that will be the answer. Now regarding this part, B part, we start with B part. Suppose this double bond, it goes onto this part. Okay, if the double bond goes into this part, the creation of a new thing, the new molecule with charges. Okay, the double bond is here. Here it will be minus R. Since the double bond is here, the minus charge, and here it will be a plus charge. Now what is happening? Let's consider this part. How many electrons? Is it planar? Yes, it's planar. Regarding conjugation, the double bond delocalization can happen since there is a negative charge here. So the next part is how many electrons? 1, 2, 3, 4, 5, 6. So 6 electrons are there. Regarding 4n plus 2 pi electron, if I substitute n with 1, so 4 times 1 plus 2 will be 6 electron. Yes, it is matching. This part it is aromatic. Now regarding this part, is it planar? Yes. Is delocalization? Yes, the double bond can move in this way. It is delocalized. The double bond can be moving around the tropylium cation. Okay, regarding electrons, 1, 2, 3, 4, 5, 6 electron in this case also. Yes, if it will obey 4n plus 2 pi electron. So this part is also aromatic. This part is also aromatic. So after the bond shifts here, this becomes aromatic, this becomes aromatic. Both this anion, this cation are stable. Since it is stable and it is aromatic, this is the answer. This charges will be standing out. In all the other cases, once the double bond shifts, both the rings will not be aromatic. Let's take this example. If it shifts here, we have a negative charge here since the double bond is coming here, and then we have a positive charge here. Here 6 electrons, it will obey 4n plus 2 pi. This will be aromatic, and in this case only 4 electrons are there. This is following 4 pi electron, which is anti-aromatic. This is anti-aromatic. Since it is anti-aromatic, it is highly unstable, and this will not be the answer. The next case will be again here through this one. If the double bond shifts here, this will be anti-aromatic. If the double bond shifts here, this part becomes anti-aromatic. So again this will not be the case. Regarding this part can never be aromatic since it is not a cyclic structure. So this is the answer which stands out, because after the double bond comes here, this part turns into aromatic, as well this part turns into aromatic. Regarding this question, it has appeared in net exam. Among these compound which has the lowest energy barrier for cis-trans isomerization. Now for cis-trans isomerization, if the double bond it is permanent, then cis-trans isomerization will not happen if the double bond it is permanent. But in some cases, the double bond, if it gets converted to single bond, so the rotation can happen. So now if it wants to be single, aromatization is the answer. If in any of the cases where once you shift the double bond, and if both the things are aromatic, both the cyclic structures are aromatic, only then it will have the lowest energy barrier. So now we have to check for where it is aromatic in both the cases. In the previous example, if I had explained that if the double bond it shifts here, this will be negative charge here and negative charge, and in this case it will be a positive charge. Both the compounds, this part it is aromatic, this part is also aromatic, because both of the rings it follows 4n plus 2 pi electron. So here single bond will be creating, and here cis trans isomerization it is possible with the lowest energy barrier. If you consider these cases, one will become aromatic, the other becomes anti-aromatic. If the double bond falls here, the negative charge comes here, so this will be 4 electrons. 4 electrons it is anti-aromatic. If the double bond falls here, so here it will be 8 electrons, 1 2 3 4 5 6, and negative charge, so 8 electrons. Again this part will be anti-aromatic, so this cannot be the answer. Okay, any anti-aromatic, what you have to remember is anti-aromatic compounds are highly unstable. So in nature you don't find anti-aromatic compounds freely available. They are not freely available. They are not freely available. So this is the answer where aromatization was happening.